Hi, I'm Dr. Lydia Knudsen, developer of Axial Stability Method, a new chiropractic approach to human biomechanics. One of the most important activities of the sensory motor system is keeping track of where our head is in space. The brain is encased in a durable shell at the top of the axial system, surrounded by powerful sensory receptors. Some of these sensors, the special senses of the eyes and ears, are well acknowledged, but more mysterious and rich in potential for the chiropractor biomechanic are the proximal senses, the vestibulo-proprioceptive system, the key to our seamless ability to know where we are in three-dimensional space without looking. So our ability to safely and efficiently interact with our environment requires 1. Sensory input from the visual, vestibular, and somatosensory systems. 2. The integration of that sensory input into meaningful, reliable data. And 3. Accurate motor output to keep us safe and achieve our desired action. So getting back to the head and neck. To monitor the position of the head and cervical spine, the visual, vestibular, and somatosensory systems interact together in what in ASM we call the Triad of equilibrium. As discussed in the concussion videos, our unique contribution as chiropractors is the unclaimed field of whole body biomechanics and the somatosensory system. Neck injuries can take down a wide swath of the sensory system, and correcting those muscle imbalances can bring the whole sensory motor system back into normal functioning. So, what are the big players in head proprioception? Somatosensory feedback for balance and postural control of the head comes in no small part from the 6 pairs of muscles found at the base of the skull, the rectus capiti. They are some of the most proprioceptively significant neck muscles. They are highly innervated and seem to have a top-down influence on the stability of the whole biomechanical system. The rectus capiti are short and loaded with proprioceptors. Individually and as a group, they are fan-shaped, and their spindle cells are more densely packed and evenly spread out in the fan. Most muscles, if you remember, have the spindle cells in the belly of the muscle. So this unusual arrangement allows the brain to get accurate information about the activity of the muscle, allowing more precise tracking of where the head is in space. As you all know, all proprioceptive data heads to the cerebellum for processing. So the cerebellum is a comparometer, but it also predicts future position and anticipates direction. The fan shape of the rectus capiti and the rate of transition from one muscle to the next allows the cerebellum not only to know where the head is at the moment, but also to predict future movement, where the head is going and where it will be next. This allows for exquisitely precise corrective and anticipatory adjustments in head position. The rectus capiti, as a group, initiate and guide movement of the head, and most injury to the head or neck will result in injury, over-facilitation or under-facilitation in some or all of these muscles. In most people, 3 of the 6 muscle pairs have direct attachments to the meningeal dura itself and may be strongly implicated in cervicogenic headaches and other cranial meningeal problems. Additionally, chronic anterior head carriage shortens these muscles and over time can cause congestion of cerebrospinal fluid and lymphatic flow. In our experience, through ASM, we are able to reduce stress on these muscles with laser specificity and allow the body to reorganize and rebalance the muscles. The importance of treating the biomechanics of occiput on atlas, and these muscles in particular, cannot be overstated. The ergonomics of the upper cervical spine seems to have a downstream effect on all of the following layers of the brain-body system: structure, muscle, dura, vestibular system via the cerebellum, and the visual system. So check out the next video of our Triad of equilibrium treatment strategy.